Hi everyone, I'm Atonu Bosak. Today I'll be presenting my BIS202 assignment 2, where I built an image object detection system on Amazon Web Service using YOLOv5, Lambda, API Gateway and S3. Let me walk you through what I did. Agenda. The presentation covers 6 areas: introduction, architecture, implementation, Lambda and API gateway, results, and finally optimization and reflection. Let's start with a quick introduction. The goal of this project was to deploy a machine learning model in the cloud so anyone can send an image and get detection result back through a simple web request. I used YOLOv5, which can detect 80 different object types, and connected it with AWS serverless service. Everything runs in Singapore, AWS region using Python. Here comes the slide 4. Architecture. The system works in 5 steps. A client sends a post request to API gateway, which triggers Lambda. Lambda downloads the image from S3, runs detection and saves the result back to S3. And IAM role called YOLOv5 Lambda role handles all the permissions between service. Now let me show you why I set this up. AWS setup. Must have slide 5. I created an IAM user and a Lambda role with S3 access, set up an S3 bucket in Singapore with 2 folders, image and results, and launched a EC2 instance called YOLOv5 server running Ubuntu with 20 gigabytes of storage. As you can see in the screenshot, everything was up and running with all status check pass. Here comes slide 6, YOLOv5. I connected to the EC2 instance through the browser and cloned YOLOv5 from GitHub and installed all dependencies including PyTorch and Bodo3. I ran into a disk quota error during the PyTorch download, which I fixed by redirecting pip's temps folder. The test run confirmed it worked, detecting 4 persons and 1 bus in simple image. Here comes the slide 7, Lambda. Lambda functions read the image key from the request, downloads it from S3, runs detection and saves the JSON result back to S3. An important issue I solved that Lambda created its own role by default, which lacked S3 permissions. Once I assigned the correct role, I returned HTTP 200 successfully. Here comes the slide 8, API gateway. I created a REST API with a post method on the detect path, connected to Lambda with proxy integration, and deployed it to a production stage. Testing with a simple curl command from my PC returned and full detection results instantly. The live URL is shown on screen. Slide number 9, result. The API returned HTTP 200 with 2 decades objects, a person at 92% confidence and a bus at 87% with bounding boxes included. The result automatically saved to the S3 results folder as a JSON file, confirming the full pipeline works end to end. Here comes the slide 10, optimization. Increasing Lambda memory from 128 MB to 512 megabyte, reduced execution by 62 times from 906 ms to 344 ms. I also observed cold start of around 520 ms on first request with warm request at no delay. Lambda scales to 1000 concurrence executions automatically, making this ready for real world use. Here comes the slide 11, reflection. The biggest lesson I am the biggest lesson I am role management Lambada's auto created role X auto created role 403 errors until I assign the correct one. I also learned the Lambada cannot access EC2's file style, so S3X as the shared data layer between them and the Amazon S3 full access policy I used is border with the needed its production. I would resist it on to only the specific actions required. Here comes the conclusion. To summarize, I successfully built a serverless object detection pipeline and AWS deployed YOLOv5 on EC2, created a working Lambada functions, exposing it through a live API, and stored result in S3 with 62% better performance after optimization. The API is live and working right now. Thank you for watching, and I am happy to take any questions. Thank you.